Recording. So, with more emphasis on the earlier material first, and then we're gonna end up with the recent one. Let's do it. Do you remember how did we start? We start with planes and equations of the planes containing the following points. So find the equation EQN of the plane through or containing through H, through 3 points. A is -1 and 2 and 1. So hopefully, I think the idea of all my reviews are like this. I go fast because we learned this before, and then it's up to you to reflect if this freaks you out, or you feel like, oh no, I kind of remember it if I review more, or you're very confident about this. Make some notes about your feelings about these problems. Put a star, exclamation mark, or something like that. Yes?
Did you upload this one to OneDrive or OneNote? Or is it on?
This is clean. So just start from the beginning. It's only a joke here. Outside of the joke, there's nothing here. Yes, I just posted a joke. But you can just start a new one. Solution. So let's imagine what is going on. There's a plane. The plane can be described with a normal vector and a point, but we'll learn it later because that requires cross product. Before that, we actually, or maybe this one is this product. Oh, it is a cross product. But how to find n? We're gonna use 3 points. 1, 2, 3. 3 points do fix a plane. So if there are 3 flies or 3 n's, 3 flies in the air, they do create a plane. That's the idea. Choose any. You just need 2 vectors to create a normal vector. This point will be used as a point, and then from product of 2 vectors, cross product, you will have an n normal vector, and that's what's gonna fix the plane. So let's have this A, B, and C. Again, you can choose any 2 just to rearrange the directions and stuff, and the answer will be the same. Vectors. First, we don't even have vectors, so A. Let's figure out the vectors first. A, B, that's the notation for the vector. Let's call it A. Is the end minus the beginning. So B minus A, 0 minus minus 1 is, now it's not parentheses anymore if you remember, it's a vector. That's going to be 1. Minus 3 minus 2 is minus 5 and 1. A, C, that's the vector B. Same idea, 2 minus 1 and minus 5. So this is the good moment to put notes. Are you freaking out right now or not?
Yeah. No.
It's kind of like okay if you know how to start, I think. And now everything becomes very traditional when it's for the plane. Plane is fixed by 2 characteristics, a point and a normal vector, normal. So we started with this idea and ended the semester with this idea. That's pretty cool. So we have a point. Let's choose A since it's over there. And now the normal vector n is coming from the n, yes, normal. A cross product of these 2 vectors we just created. Let's write down A cross B. And very fast, we're checking if you remember how to do that. I, J, K. 1 minus 5 and 1, 2 minus 1 and minus 5 equals blah blah blah, calculating carefully, multiplying 26, 7 and 9. Remember, the result of the cross product is a vector. That's why in Russian we call it a vector product. Not only actually, in Europe it's also known as a vector product. The point is A, so equation will be point A is given as minus 1, 2, and 1. Normal vector is 26, 7, and 9. And then you make a mistake by building the equation, because I saw it on the test, people kind of mixing up what to do and how to do it. I just reviewed it this week. What is the equation of a tangent plane? Remember, the slope here, the slope, is this components of n. So 26 will be times the variable, and then x minus the shift, minus 1, which is plus 1. One more slope as 7 y and the shift minus 2. One more slope, and then z minus 1 equals to 0. So that's how you don't mess up. You remember that n here is working like a slope. It tells you the direction of the plane, so it will be multiplied by the variable. Point is the shift of the plane. It's a little bit to the left, to the right, down, and so on. Yes. Nice. So can you do that on the test and so on? Parameter, then yeah. Now let's keep moving. You can stop me if you want, but if you don't stop me too much, we can cover a lot. Just kind of letting you know. Find the parametric equations. Yeah, your favorite one. Find the parametric equations. Equation of the what? Tangent line. See, I told you the tangent line will be hunting you from calculus 1 to calculus 3. Equation of a tangent line. The tangent line needs either a point or a function. In this 3D case, we're learning it with the curve. With the curve at, and the point is, okay, so with the curve, they give you the curve, r, I know, r of t, t squared plus 1, t cubed minus 1, t to the 4 plus t squared at the point 5, 7, and 20. And now you'll be like, oh, is this new material? What is going on here? Not really. Here it was the very beginning. It was exam 1 actually. They gave you this, so they want you to solve for t. Remember you had this thing when you were solving for t? I knew that you don't remember. Solution. The idea is that this is 5, this is 7, and this is 20. And you can solve for t like that. So, because, let me sketch the graph. There is a curve, that is my r of t. That's a curve. Here is a tangent line over here. That's the one we're looking for. Here's the point, 5, 7, 20. We need a derivative of r prime at something, and we don't know at what. So we will have to figure out what this t is. R prime at what kind of t? T is not given, the point is given instead. So let's solve. Either one or all of them will give you one same solution. So don't choose the last one, that's kind of hard. T squared plus 1 equals to 5. T squared equals to 4. T equals plus or minus 2. Okay, I got two solutions. That is not good. Let's check second one. And that should give you a unique one. T cubed minus 1 is 7. T cubed is 8. So T is 2. Okay, so minus 2 is extra. We just need plus 2. Plus 2. T is 2, and that's what we're going to plug into the derivative. So this will be 2. Now we know. And you can check the last one. 2 to the 4 plus 2 squared is 20. And now we're building a direction vector. Wow, what is direction vector? Remember, it was a long time ago. Second step, we have a point now in parametric equations. That is 2, not x, y, and z. Direction vector. Direction vector was a synonym of a derivative vector. Basically, let's differentiate the given function with respect to t. Not a function, a vector. So it's going to be t squared plus 1, that's 2t. T cubed minus 1, 3t squared. T to the 4 is 4t cubed plus 2t. Too fast? Let me slow down. Plug in the point. And that builds the equation, but you still need to know how the equation looks like. I remember people stuck with that as well. So we have a derivative. Remember, the equation needs a derivative and a point. Point and derivative at t equals 2. So let's plug in r prime at 2 is 2 times 2 is 4, then it is 12, and then 36. That gives us So let's see, a point is given from the beginning. Let's see, 3. We need a point which was given 5, 7, and 20, and a slope, which is in this scenario, 3D-dimensional vector calculus, is a derivative of your r at the point we found, like so. A point and the slopes, all the slopes. That creates the answer. X of t is, y of t is, z of t is. Remember, slopes, those are my slopes, are multiplied. So it's going to be 4t, 12t, 36t. And then the point gives you a shift. So plus 5 plus 7. It's like mx plus b plus 20. So the idea is y equals mx plus b. This is what we did here for all of them. Do you remember this? I don't remember this. I was like, oh, that was a long time ago. It feels like previous life. So that's why you should review. It's not very challenging, but it's kind of annoying, and you have to review this. So a point and slopes. And that helps us to create, I can see just a second, a parametric equation for the tangent line to the following curve at the given point. Yes?
When we solved for t, was there like a reason why we didn't use the e part? Like
Oh, it's too complicated, but you can. Try.
Would it give us the same answer?
Yeah.
Oh, okay.
But try to solve it. I don't even know how would you solve it. Factor out. This one is better for checking. 2 to the 4 plus 2 squared equals 20. Check mark. So you always choose the easy one.
Then you can factor out t squared.
Yeah. Yeah. So, more questions? Are not too bad. Find the position s of t out of the particle. This is the one you guys actually like. So find I also like this type of questions in all my calculuses. Calculus 1, 2, and 3. I always like to put velocity and position and acceleration problems because I found them interesting but easy. Students usually do well on these, so I kind of like this. S is not given. We want to find the position of a particle. Given what? The acceleration. Given the acceleration as a vector this time. So that's the new thing. In the vector calculus, we'll learn that things can be given as a vector. And velocity is 4, 0, minus 2 at t equals 1. And initial, it's called initial value problem. You know it from differential equations class. Initial position is also given. To solve for C is 1, 2, and 3. This is the same thing we did in calculus 1 and calculus 2, to be honest. So we were integrating twice, but just everything now is in terms of vectors, and that's why it looks unusual, but the idea is still the same. The idea is when you have R, that is now, well, R or S. So R in vector calculus, S in physics, that is a position. You differentiate derivative and you get your velocity. You differentiate derivative and you get your acceleration. So guess what you need to do to go back? You integrate, and you integrate again. The problem with integration is it does not give you the unique answer, and that's why initial value is important. So as always, we call it initial value problem, even though it's in terms of vectors. Let's do it. These ones usually, honestly, students like this. So trying to be optimistic. Solution, let's find one. Let's find V first from acceleration. So we're going to integrate a of t dt. I was just teaching this in my calculus 1 class. So it's going to be integral of 2 That's going to be 2t, and let's call it C1, C2, C3, or A, B, C. Which one you prefer? Let's do A. Integral of 3 is 3t plus b. Integral of 2 is 2t plus c. A, B, C are my constants, which is like C1, C2, C3. Any book decides differently on that. You can call it whatever you want. But this is my velocity, which is a family of functions shifted up and down by A, B, and C. But we will use initial value, which says at 1, v at 1 is given as 4, 0, and minus 2. So let me plug 1 everywhere. It will be 2 plus A, 3 plus B, and 2 plus C, which should be 4, 0, and minus 2. I'm using this information over here. This is also called initial value for velocity. From here we have equations now that 4 is 2 plus A. That is a property of vectors that you can make corresponding components equal to each other because of this equal sign. So I'm solving this equation between two vectors. 2 plus A is 4. Right away, A is found as 2. 3 plus B is 0. So right away, B is minus 3. 2 plus C is minus 2. So right away, C is negative 4. Thank you. So now we have a given velocity, and you repeat the whole process. Velocity, I will put it in different color. V of t is 2t plus A, which we found is 2. 3t plus B, which is minus 3. 2t plus C, which is minus 4. And this is the vector. Put it in the box because we need it. So imagine this is a written problem, several steps, or maybe multiple choice problem, but you only need to do once one of these. That is still a very typical calculus 1 initial value problem. When we learn integration for the first time and we learn plus C, we give this problem, but just in your case, it's in terms of vectors. Finally, integrate one more time and repeat the process. So S of t will be integral of v of t dt. Unfortunately, the integral becomes harder. Well, not the integral, the result. 2t plus 2 gives you t squared over 2, so it's just t squared, plus 2t plus a. You can call it new variables like a1, b1, c1, but since you already solved before, you actually can name it a, b, and c. That's okay. 3t squared over 2 minus 3t plus b, and 2t squared over 2, which is t squared, minus 4t plus c. Are you catching up or too fast? Let me drink some water and then we'll see. We do know that at 0 it should be 1, 2, and 3. Thanks God it's at 0, because if it's not at 0 it will be too much solving and stuff. But at 0 everything is kind of 0 except a, b, and c. So that will be easy. S at 0 is a, b, and c. 0, 0, 0. Plus a plus b plus c. But it's supposed to be 1, 2, and 3.
Isn't it t equals 1, not t equals 0?
Let me check.
What's initial position?
Yeah, initial. Oh, good question. Initial position is at 0. That they did not mention what t is, but they hoped you guess. Yeah, thank you. That's a good one. IA t is 0. Thank you.
All right.
That's a tricky thing, right? Actually, that's kind of mean to put a trick like this. So at 0, it's 1, 2, 3. Here it is 1, 2, 3. So A, B, and C are immediately found. And we can finally finish the problem. Thus, the answer is S of t will be t squared plus 2t plus a, which is 1. 3t squared over 2 minus 3t plus b, which is 2. T squared minus 4t plus c, which is 3. Done. Kind of more work than actually something new. Did you like this problem?
Yeah.
No,
Yeah? No. People are like, no. It's not too bad. It's kind of more writing than new stuff. And then we learn about tangent planes, normal vectors, and so on. Level surface, remember level curves. There is a picture on the exam right now which is asking you like, is this going positively or negatively? And I don't like it. I'm definitely gonna change that. But there's a picture there. And I'm like, I don't like having tricky pictures in the test, to be honest. So, problem number 4. Problem number 4 is, find the equation of a tangent plane to the following surface. Again, equation of a tangent, but now plane of the tangent plane to the surface at the surface, let's write down the surface x, y, z equals z cubed at 1, that's a point, 1, 4, and 2. Again, how do we build the plane? The plane has something to do with the gradient and stuff like that. And definitely normal vectors, you remember. But let's see what is happening here. Solution. This was a little bit advanced, more advanced material. Remember, step 1, always write down, let me put it in green color to remind you. So, did you get it? Find, yeah? Find the equation of the tangent plane to the surface xyz equals z cubed. That's a weird notation for the surface, and that's why we should fix it. Write down in the form as f equals to 0. So, it is actually xyz minus z cubed equals to 0, like so. We will be working with this. That is our f of x, y, and z. X, y, z minus z cubed. That is what's happening here. Now, we need a normal vector. Recall that the gradient is perpendicular to the level surfaces. This is what we're going to call level surface, because it's equals to 0, remember? Level surface. Normal vector shows up from this idea. Step 2. We need normal vector, right? We know that, okay, there's some kind of shape like so. F, this is level surface, right? You remember those are like circles that represents how tall the mountain is. F is 0. However, the gradient is always perpendicular to level surfaces. That's why gradient tells you where is the best way to go down from the mountain. That's what we call gradient descent. Gradient minimizes or maximizes stuff because it's perpendicular. Someone is spamming me. I need to mute it. Yes. So, since we will write it down, recall that, well, all this review is kind of recall. The gradient is perpendicular, that's my notation for perpendicular, to the level curves, level surfaces. So, we can write down that we will find the gradient of the function we just built, the surface we built. Gradient is the collection of partial derivatives. While the recent thing we just learned, curl and divergence. Curl is adding up together everything we just, all the partial derivatives. Carlos, are you sleeping?
No.
Are you meditating?
A little bit.
So, partial derivatives. And that's also, this problem is good because it also teaches you or checks you remember how to take partial derivatives. With respect to x, x is the only important guy. So y, z is a constant, they will stay. Minus z cubed, that is 0, comma. With respect to y, your brain quickly switches that y now is important. So it's going to be xz minus 0. Now z is important. With respect to z, that's going to be xy minus 3z squared. So you're checking how do you take partial derivatives. We just did that. Very nice, very fast. And at the point. The point was given, let's check, 1, 4, and 2. So n is going to be normal vector matches here with the gradient because gradient is perpendicular to the surface, level surfaces. So you can plug the point 1, 4, and 2. That's what we need. My point, which is given, because we need n at the given point, not literally everywhere. We need it fixed normal at the point. Plugging in into this function, into this vector 8, 2, and minus 8. You can check. I just plugged in. The point is given. So step 3, build the equation. We have all the things we needed. A point, 1, 4, and 2, and a normal vector, which we found knowing that gradient will give it to us. And the equation, again, we already did it like third time today. 8 goes in front of the variable x minus shift minus 1 plus 2 in front of the variable y minus shift 4 plus minus 8 z minus 2 equals to 0. Equation of a tangent plane. We found normal from gradient and the point was given. How do you think about that? So we did like tangent plane so many times now, it probably hints you that it will be on the exam, or else why we're doing so many times. And that's what I warned Calculus 1. I was saying, you guys have to learn equation of a tangent line. It will be hunting you for a year and a half at least. Example number 5. Let's go chain rule, your favorite thing. Yay, chain rule. Doo-doo-doo. Yes?
Do we need to know linear approximation?
I will check carefully. I did not finish creating the exam, so I don't know yet. But on Saturday, you can ask me because it will be probably ready. Maybe, we'll see. But I don't know yet. And we keep going with the review, so maybe it's there. Do you like linear approximation?
Yeah.
I usually don't like it, to be honest. Chain rule. I do like chain rule. It is on the exam. So, do you check everything?
So much. Yes.
Good job.
Thank you so much.
Thank you. Have a good day.
You too.
Chain rule. Let's do this. Find partial. Find partial derivative of f with respect to s, where f is a 4-dimensional function. Oh, it's 5th-dimensional function. Depends on x and y and z and w. It has 4 inputs, so the output is a 5th dimension, as you understand. And each depends on 3 variables. Okay. S squared, y is r squared s squared, z is r cubed, and then w is r e to the s. Okay, that's not 5, so those are all s. And actually, I don't know, I don't need to have a diagram to understand it, to be honest. So I was trying to teach you not to have a diagram, but if you want to have a diagram, you can. The diagram looks like so, if you want to. F depends, let's make it fast, has 4 inputs, x, y, z, w, and each apparently depends on 2. Either they are there or not. It depends on 2 each. What 2? S and R, S and R, S and R, S and R, S and R. Now I can ask you to go to any location. I can ask you to go over here, or I can ask you to go over here, and so on. And you need to know how to do it. So I just see it as a chain rule. The chain rule is derivative of the function outside times the function inside, plus derivative outside times the function inside, and so on. So let me tell you how I know it. There are formulas, if you remember, but I think memorizing formulas is more complicated than understanding the process. So they ask us to dig into from F to S. That means they never actually told me which path we want to choose, so we need to have all of them. Right? 4. What?
Where's the function f?
F is not given. So it will be just f. We can actually create some. We can create some if you want, just as a practice, but it's not necessary. So f, for example, I don't know, x squared plus y squared plus w. Whatever. Plus z. Fine. Plus z.
You need the function, right? Because
Not necessary. You can just write down f prime. And then keep it general.
okay.
Yeah. So for example, this is the function. Thus, they want us to have all the passes written 1, 2, 3, and 4. I'm imagining having pockets in my pens, and then each pocket goes deeper and deeper. So you just keep adding those all cases. If you ever take classes with probability, that's kind of the same thing. What is probability to get into level S? Either this pass, or this pass, or this pass, or that one, and so on. So you have to indicate all of them. I know. Partial derivative of f. That is capital F. Let's keep it, no, small. Of f with respect to s. So is it capital or small? I think it's small. Yeah. Fix it to small. With respect to s has 4 different choices. So I start with the first one on my diagram. The first one is a partial derivative of f with respect to x first. So this is my first level. And then to get to the next level, deeper pocket, I will do times, which means and. And means times in math. Or means plus. So times, which is and. Partial derivative of x with respect to s. Because x depends on s and r, it's partial derivative. Then I say or. So again, see the difference. It's actually logical. If you take discrete math, you know and is product, or is a sum. Then I say or, there's one more opportunity. You can go to the pocket named y. Derivative of f with respect to y, and then you have to dig deeper, y with respect to s. Do you understand this? So this is how I see it. I don't need formula to create this from scratch. And that's why I like it. Keep going. There's one more opportunity. I can go to the pocket called z, and then I have to dig z into s, because there are 2 variables, s and r. And finally, the last choice is to go into the pocket called w, and then w have to be differentiated with respect to s. So this is the formula you just created in front of you. And now you actually do the partial derivatives, carefully looking at whatever you need to be looking. This is the function f, and this is the box for all of these variables. So derivative of f with respect to x is 2x times x with respect to s. I'm looking at the first equation. That's 2s. Plus derivative of x with respect to y. That's 2y times derivative of y with respect to s. R squared, rs squared gives you r squared times 2s. Plus, let me jump down. Derivative of f with respect to z is 1, because it's just z there, times derivative of z with respect to s. I'm looking at z in my list. It's r cubed. There's no s there, so it's just 0. Plus derivative of f with respect to w is 1, times derivative of w with respect to s. That's r e to the s. So it will be r e to the s. Derivative of exponential function. Done, and this is the answer. This one goes away because it's 0. So it's very interesting, because I could ask you just to find partial derivative with respect to w, and then this is how you stop. From f to w, you're done. Or I could ask you to go from f to r, then it will be different. All the last steps will be different, but the first steps will be the same. These steps will be the same because they represent the first pocket, and the last steps would be different because we would have to dig into the pocket called r. So that's kind of the idea here. Yes?
Don't we need to substitute options for x and y?
That's a good question. So either you keep it like this if we don't ask you to go back, or indeed you have to solve for s. Or you need to have it with everything with respect to s and r. So that is why it was easier to keep it just function. See this x and y? Yeah, you're not supposed to have the answer with so many different variables, since they have relationship between them. So let's multiply x. Let's change x back to s squared. times 2s plus, let's change back y to be r squared s squared, r squared times 2s plus, nothing to change here, and it's actually 0, and nothing to change at the end, it's r e to the s. And this is the simplified version, and we have the answer in terms of r and s. So this is in terms of r and s. That's the idea. Thank you. Yeah.
Do you care which form it is in?
Yeah, usually this is the correct answer. You're not supposed to have a mix of inside and outside variables. If you know that x is s squared, you have to change it to s squared. Yeah.
Can you just change it all to y back there if you want?
Let's keep going. Yes.
So how would you solve it? Like in the beginning where you didn't give us the function of f? Like in, how
What?
would we have solved it?
What do you mean solving? We're not solving anything. We're just finding the derivative. Yeah, we just keep it like this.
If we didn't have that x squared plus y squared
Yeah.
plus w plus z, would
Oh.
it just be 1?
Then you do it like this. That is a good question. Originally, it was just a notation as df with respect to x. That is a general notation. So that's why I did not have to create the name for that actually. But then you cannot plug in your x. So you know that x is s squared and so on. So we basically keep it a general case.
Oh, so we keep that.
Yeah.
And then you just derive the s. Okay.
Yeah. And that's why it's actually common, especially in engineering and biology, to keep this very general, because then you can use different functions, plugging them into the formula. And computer scientists, for example, they code this, and then they can change f into anything we need for a particular case. And for the last 10 minutes of saddle point and stuff, we're gonna do it on Saturday. This takes a lot, but let's do something shorter. How about vector fields? That is also very long. Just a second. How about disk radius 1? Why all these problems are so long? A ball. Oh, we did this one actually last time. Okay, this one is good. Let's do this one. Spherical coordinates, your favorite one.
What?
I know. Spherical. I knew Jacob will say that. Triple integral x squared plus y squared plus z squared. Yes, it is there. I already saw spherical coordinates there. Here it is, where E, now we don't tell you which coordinates to use, but if E is the cylinder, probably cylindrical coordinates are good. If E is the ball or a sphere, then guess what? Probably it's nice to use spherical coordinates of radius 2 in the first octant. Quadrant is in 2D, and in 3D is octant. Yeah, but you're right. Yes?
Will this test be like test 3 where we don't get cylindrical? We only get
I will think about that. That's a good question. I don't know yet.
We get rid of spherical foot cylindrical.
Yeah.
Let's just have one problem.
Can we just not?
Yeah.
100% of the grade.
Yeah, right?
So we had this picture before actually this week. We already had the ball, but it's only in the first quadrant. So we kind of guessing like, yes, spherical will work the best. Rho is my radius from 0 to the edge, which is 2. Phi is going from north to south pole. And then the rotation in 2D, that is ugly, rotation in 2D is done by theta. So I think you're already pro in that. We need to remember 3 important things. The formula is x squared plus y squared plus z squared gives you what? Rho squared. So this will be important, especially if it's multiple choice. Don't lose that part. And the tail of the integral. So let's write it down. Integral over E, x squared plus y squared plus z squared. Everything was squared, was it?
No.
Oh, I did not square. So, oh, it was squared. Sorry about that. Squared. It will be more interesting if we do that. like so. So it will be rho squared squared. That immediately gives you the idea. Let me go back here. That immediately gives you the idea that this is a rho squared. And then we have d, for now we just have dx, dy, dz. dx, dy, dz. Converting to spherical. Converting to spherical. Spherical, yes. Nice. Сферический. It's easier, I think. Сферический. Сферические координаты. So, that will be a double integral, remember? Because now we have... Why is it double? It's still triple integral. Bless you. So, you have here, let's see, rho squared. It is squared, and the important tricky part is the tail of the spherical integral. What is the tail?
Squared sine phi.
Exactly. Rho squared sine phi, then what?
D rho d phi
D rho, d phi, d theta. Let's do, doesn't matter, I guess. D phi, d theta, like so. So, theta and phi are going from what to what?
Isn't phi
0 to pi over 2.
1 over 4 pi?
Why is both are from 0 to pi over 2 because of the first octant, right? Mm-hmm.
But isn't it in the first option should be pi over 4?
No, pi half. So you imagine in 2D it's first quadrant, so that is pi over 2, and then in 3D it's still pi over 2. So you just have third dimension there.
Okay.
0 to 2.
From 0 to 2. From 0 to 2. So, and you just quickly solve all of this.
Yeah, just quickly solve.
Just quickly. I know, I should not have said that.
Just take 1 minute, guys.
So, one thing is quickly, we don't see any function with theta, but theta is from 0 to pi over 2. That gives you right away, what?
Pi over 2.
Pi over 2, immediately. The length of the interval is the answer for the empty integral. Now, what we do have is a function with terms of rho, that is rho to what power? 6. Good job. 6. Rho is from 0 to 2. And we do have integral in terms of phi. That is just sine. Sine is from 0 to pi over 2. And that's why it's actually not too bad. Rho to the 7 over 7. Sine gives you minus cosine. Plug the top minus the bottom, and you get 64 over 7 pi. This is a good multiple choice question without solving it, I would say. In the multiple choice, I see they want us just to know how to build the integral. So this is a good one. You saw it in exam 2 and 3. They give you lots of integrals and you need to choose the correct one, which is kind of blurry in your eyes because you see lots of triple integrals there. But try to eliminate the obviously wrong ones. Obviously wrong ones will not have the tail. Obviously wrong ones will not have this thing in, and so on. Usually there are two looking like each other, and then you choose from that. Good enough for today, and tomorrow we're going to keep going 10 a.m. from 10 to noon or so.